Anytime you download a new piece of software from the internet, there's always the question of trust. Is this the exact replication that the developer produced, or could it have been compromised on the way to getting to your computer? In Bitcoin, we answer this with one principle. Hi, I'm Satoshi, and in this video, we're going to walk through verifying the latest release of Bitcoin knots using PGP. First, we will talk about some key concepts and terms so you can understand how the process works. Then, we'll walk through a step-by-step instruction on each operating system. The process of verification does two main things. It'll ensure the integrity and the authenticity of the software you're about to run. We will use a tool called GNU Privacy Guard, or GPG for short. At a high level, here's what's happening. We're going to download 3 files: the correct version of Bitcoin knots for your operating system, the SHA-256-sums checksum hash file, and the SHA-256-sums.asc signature file. So every single operating system has a version of Bitcoin knots, and all those versions have been hashed and compiled into the SHA-256-sums file. Hashing is like creating a digital fingerprint. It turns any data into a fixed size code that will change completely if any of the original data has changed. We use hashing to link data securely. But just checking your version against a hashed version is not enough. Anybody can post a malicious version with a hash of that malware. That's why developers will actually sign this checksum file with their private keys, creating the SHA-256-sums.asc file. This proves the checksum hash file really came from them and is authentic and has not been compromised. PGP works with private public key pairs. The developers will use their private key to sign, and we can use our public key and GPG to verify that that signature is a good signature. We can find these public keys stored in the official GitHub signature repository for Bitcoin knots. It'll be in the guix.sigs page under a file called builder's keys. What we're also going to do is download and import these builder's keys. Although many developers are listed in this file, only a few of them will actually sign the release. If new developers join the builders list in the future, you just need to import their individual keys, not the entire repository again. So there are always more advanced steps that you can take. One good practice is to verify the developer's fingerprint, which is a hash of their public key, against other third-party trusted sources. This could include a personal website, their verified social media account. You could put it into a key server, or ideally, you would verify it directly from the developer when you see them the next time at a conference or a meetup. After you're satisfied that these signatures are good and you have a good level of trust in them, we can then compare the checksum hash file against the release you're going to run. If that is okay, then you're ready to install Bitcoin knots. All right, let's get into the details. Chapters are provided, so jump ahead to the operating system that you're going to be installing Bitcoin knots on. So here we are on a Mac. And the first thing you want to do is get into your terminal. Don't worry, the terminal is not that scary. These commands are very straightforward and you got this. The easiest way to do this is press Command spacebar, then hit T and terminal should come right up. And there you are. I'm going to make this a bit bigger. If this is your first time using the terminal, you need to be sure that you have the tools to use certain commands. The first will be to install Hombrew. Homebrew is like the app store for the command line, and we use it to install other tools. So copy this command from the description, run it, just wait. And these 3 commands that show up here, you need to copy and paste them in and run them as well. And these commands are going to make sure that the brew command is always available whenever you open the terminal. Okay, now you can check what version of brew you're running. And now we're going to use brew to install git. So run brew install git. You can check on the version. And now we're going to use brew to install GnuPG. Great. Now you have the tools you need to get started. Now you need to go to the official Bitcoin Knots website to get those 3 files. And usually it'll sense what operating system you're on and it'll have that file right here ready for you to download. You're going to also want to get the fingerprints, which is the SHA-256-sums checksum hashes, as well as the SHA-256-sums.asc signature. All right, so we got those 3 files. Go back to the terminal and go into your downloads folder. You do that by changing directories. Oops. Now we're going to clone the official Bitcoin Knots GitHub signature repository. And this will be the file that has all of the public keys to all of the developers or builders that contribute to Bitcoin Knots. And we do that by going to the official GitHub website for Bitcoin Knots. And then right here, the guix.sigs is the signature repository. Copy this link. Back in the terminal, run git clone and paste that in. Now we need to import the builder's keys. So that's the file within the signature repository that has the public keys. And we do that by running this command here. I'm just going to copy it and paste it. All the commands are in the description. So we've imported 16 different public keys to all these developers. Now, only a few of these developers have actually put their signature on the .asc file, but now we have the entire repository for every developer that contributes to Bitcoin Knots. So for the next time that you verify a release, you won't have to do this step of downloading and importing the builder's keys again. Okay, let's clear this. Now we want to verify the authenticity of the signature file that we've downloaded. And we have the public keys imported, and we verify by running GPG --verify and then .asc. And we can see here good signature from Luke Jr. We can also see good signature from a number of the other developers on this release. We also see this warning here, this key is not certified with a trusted signature. To remove this warning, you need to build what is called a web of trust. So first, you would take the fingerprint of the developer's public key, which is a hash of their public key, and verify it against another trusted source. This could be their website, a verified social media account, a key server, or the best way possible would be actually in person. Then you create your own private public key pair, assign a trust level to each imported public key, then you sign the public key with your private key. Then you won't see this warning. And we're not going to get into it into this video, but just know that's another step that you could take. Okay, so we've verified the authenticity. The last step is to verify the integrity between the hashed file and your release file. And we do that by running this command here. I'm going to copy and paste. And we see here that it's okay. So our release file matches the hashed file, and we're good to install this version of Bitcoin Knots on our Mac now. So I'm still here on my Mac, but I'm going to go into a secure shell to connect to a Raspberry Pi. In the terminal, run SSH, your username, and then the local IP address, password. Okay, now we are in a Linux environment. And the first thing you want to do is make sure that you have GnuPG installed on your machine so you can run those commands. And I have it. I'm going to check the version. And depending on your Linux operating system, the commands to install it will be a little bit different. So check those out and make sure you install the right one. And the first thing you're going to want to do is go into your downloads folder. If you don't have a downloads folder, so if nothing comes up when you press change directories download, you can make a directory by mkdir and then downloads. So now we want to get those 3 files. You need to go to the official Bitcoin Knots website. This is not the right version for the operating system I want to download. I'm on a Linux and it's an Arch64. Right click and copy link address. And you run wget and paste that in. Blank screen, and we're going to do the same thing for the SHA-256 sums checksum file and the SHA-256 sums.asc signature file. Good, and if we list it out, we can see we have these 3 files. So now we need to download and import the developer's public keys. And we do that from the official Bitcoin Knots GitHub signature repository. And in that, there's a file called Builder's Keys where all the public keys of the developers who work on Bitcoin Knots are stored. So let's go find that. Bitcoin Knots GitHub. This page here, the guix.sigs, this is the file with the public keys. We are going to do the same thing, copy, and this time we're going to run git clone those signatures. So now we need to import the builder's keys file. And we do that by running this command. And there we go. We've imported 16 public keys. So not all the developers will sign the release, just a few of them. And once you have this whole signature repository, you're not going to need to do this step again for future Bitcoin Knots releases. So keep that in mind. So now we're going to verify that the signatures in the .asc file are really from some of these developers. And we do that by GPG-verify. And then we're going to verify the .asc file. Okay, so we can see here, good signature from Luke Dasher, good signature, all good signatures. We also see a warning here, this key is not certified with a trusted signature. To remove this warning, you need to build what is called a web of trust. So first, you would take the fingerprint of the developer's public key, which is a hash of their public key, and verify it against another trusted source. This could be their website, a verified social media account, a key server, or the best way possible would be actually in person. Then you create your own private public key pair. assign a trust level to each imported public key. Then you sign the public key with your private key. Then you won't see this warning. This is one of those more advanced steps, and we're not going to get into it in this video, but maybe in a later one. And the last step is just to verify the integrity of the checksum file against your release file. And we do that with this command. And we see here, okay, so that means that the release that you're going to run is the right one in the hash list, and it's been signed by the right developers. So you're good to go and install Bitcoin knots. So we're here on a Windows machine, and there are a couple prerequisites before we get into verifying Bitcoin knots. We're going to use the command prompt. So you can start searching that in your toolbar. Get this queued up. So in order to run GPG commands, we need to have GnuPG installed on our machine. For Windows, it's a software called GPG for Win, and you can check if you already have it by GPG -- version. And I don't have it on this machine, so we need to go and download and install it. So just search for GPG for Win. It's this one here. Okay, now before we download and install and trust a software from the internet, we need to verify it. But you're kind of in this chicken and egg scenario if it's the first time you've ever downloaded and installed GPG for Win, because you can't run those commands without the tool. So one thing you could do if you had another computer with GPG already installed on it is to download the release file and download the PGP signatures, import the signatures, run the verification. If the signatures are good, then you could transfer those files to the Windows computer you want to run GPG for Win on. But if you only have your Windows computer, that's not really realistic. And there are a couple things we can still do to work around that. So here on the main website, there is a button with check integrity, and there are a little bit of instructions here. It says usually you can use Microsoft's own methods to check that the installer is signed by one of the current code signing certificates listed below. What this means is Microsoft has a list of trusted certificate authorities who have verified the digital signatures on this software. Once we have both the installer for this release and the signature file, we can inspect the properties of the release before we install it and see if Microsoft recognizes it. So what we are going to do is get the PGP signature. So it's this file here. Oops. We'll go to the download page and we will download it. We're not going to give them any money today. Okay, so now we have two files. And if you go into your downloads folder, right click on the actual release file, go to properties. You see a tab here called Digital Signatures. And we get a name of the signer, which is G10 code GmbH. And if we look that up, which I have searched already, so this is the company founded by the principal author of GnuPG. His name's Werner Koch. So this can help us trust and feel more confident that this is the right release coming from the right developer. So the next thing we want to do is hash the release file and check it against what is listed as a hash for the release that's here on the website. Let's go into our downloads folder in the command prompt and just change your username to what it says here beside users. So for me, it's just you. And now we're going to run the hash command on our release file. To be able to copy and paste it pretty easily, you can list out what's in your folder by running dir. And it's this one here. I'm going to copy it. And then the command is certutil-hash file, copy, capital SHA 256. All right, here is the hash. Copy. Let's put it in a notepad. And we see this is the release. So we go to this page of check integrity. And the SHA-256 checksum for the right release is here. Copy that. And we can see they match. So we'll double click on it and just go through the steps of installing. So these are some extra advanced tools that you could install, but you really only need GnuPG. And just put it in the default folder. All right, now we can try that again, checking our version. Let's go to the official Bitcoin Knots website and download the right version for our machine. So the digital fingerprints is the SHA-256 sums checksum file. So we'll download that, as well as the SHA-256 sums.asc signature. After we have the three files, we need to now go get the signatures that we're going to verify. And we can find those on the signature repository on GitHub for Bitcoin Knots. I've got it queued up right here. The guix.sigs is the signature repository. And within this whole folder, there is a file called builder's keys, and that's what we're going to import. And on a Windows, we do this by pressing the green code button. We want to download the zipped file. Now we're going to go to our downloads folder, and you're going to want to extract it. And the default path is fine. Okay, let's go back to the command prompt. And we're going to change into that builder's keys file. So you want to copy and paste this command, and we're going to run it. So now we're in the builder's keys file, and now we want to import those keys. So now we run GPG -import. Give it a minute. Okay, so we've imported 16 keys. Now we will go into the downloads folder, copy and paste this command. Now we're in our downloads folder. Now we need to verify the signatures, and that is GPG -verify, and then the SHA-sums.asc file. So good signature, good signature, good signature, all good signatures. We also see a warning here, this key is not certified with a trusted signature. To remove this warning, you need to build what is called a web of trust. So first, you would take the fingerprint of the developer's public key, which is a hash of their public key, and verify it against another trusted source. This could be their website, a verified social media account, a key server, or the best way possible would be actually in person. Then you create your own private public key pair, assign a trust level to each imported public key, then you sign the public key with your private key. Then you won't see this warning. This is one of those more advanced steps, and we're not going to get into it in this video, but maybe in a later one. So now the last step is to verify the integrity of our release. So now we're going to hash the zipped file of Bitcoin Knots that we have downloaded, and we are going to then compare that hash against the checksum file list and see if they match. And if they do, we know that our version that we've downloaded has not been tampered with, and we're good to run it. So let's list out what's in our downloads folder. by running dir. And we can see the version of Bitcoin knots here. So we want to copy this. I just right-clicking copies it. Then run cert util dash hash file and SHA-256. And this is the hash. Copy it, put it in a notepad. Now we need to see the list of hashes in the checksum file. And we do that by type SHA-256 sums. So all of the versions of Bitcoin knots are here and hashed. We need to find the same one. So this one here, Win64 setup unsigned. This one here. So then take this hash, copy, and put it underneath to compare. And it's the same. So we verified the authenticity with the signatures. Now we verified the integrity of the hash list, and we're good to run this version of Bitcoin knots. Verification may feel like a small extra step, but it's what protects you from running altered or malicious software. By checking hashes and signatures, you're taking responsibility and not outsourcing trust. Choosing to run Bitcoin knots carries the same spirit of independence, diversity, and making your own decisions. Thanks for watching, and if you liked, leave a like, comment, subscribe. I hope you have a great day, and as always, my friends, stay sovereign.